Right, so this is the Chemistry 5.2 Acids, Bases and Salts past paper questions. Question 1, which is quite a common question, maybe using different types of acids. The diagram below shows some reactions of a common acid, and you have to work out what the acid is and what other things are being produced during different reactions. So the first one, acid A. Now straight away I can see that magnesium sulfate is being made, and so is copper sulfate. So coming from that acid, I know straight away it's got to be a sulfuric acid reaction. Then gas B, if I'm just adding magnesium, that means that it's going to be a hydrogen gas reaction. So gas B is hydrogen. Then moving on to gas C, I can see that copper carbonate has been added. Carbonate, automatically in my head, I'm thinking it's going to be a carbon dioxide reaction. So you make copper sulfate and carbon dioxide. Colourless solution D. So sodium hydroxide is a base. You've got a dilute acid that we've worked out to be sulfuric acid. That is a neutralization reaction. Acid plus base goes to water. So colourless solution D, also it says it's colourless, is water. Black solid E. So black solid E, this is a specified prac that you will have either done in class or watched the YouTube video on. So specified prac, black solid, copper oxide is a black solid. It's a really common question that you get asked, so do remember it. So copper oxide, and then what does that make? Blue solution. As soon as you see blue solution, you should be thinking about copper sulfate, because that is known as the blue solution that you guys have to know for your exam. Moving on then to question number 2. So question number 2 is again, a common kind of question, looking at the results that the graph gave you. So an experiment was carried out to investigate temperature change which occurred when you add sodium hydroxide to hydrochloric acid. So again, a neutralization reaction. They show you the setup of what they're doing in the experiment. So you've got sodium hydroxide solid added to hydrochloric acid, which is a liquid. They're measuring the temperature, and they've got it set up a little bit quite fancy. They're measuring their results on a computer, okay, to limit the amount of error and getting rid of human error, essentially. Then it goes on to show you the graph produced by the computer. So the graph produced by the computer. Now, this kind of question tends to be on 2 pages. So if I just give it a look. So it says there then, question A, use the graph. So using the graph, you need to work out what's going on. The highest temperature recorded. And as you can see, I've drawn a line. I haven't just guessed, I've drawn a line. Each of them little points is going to be equal to each of them little squares is going to be equal to 0.2. So the highest temperature recorded was 21.4 degrees, okay? The next thing you need to do is an increase, so the total increase. So when it was starting, it's on 19 degrees. The total increase, so the highest value you've got is 21.4. So take them away from each other and you end up with 2.4. So that's the biggest temperature increase that you will see in that reaction. Moving on then to question B, write a word equation for the reaction that takes place. So like I said, it's a neutralization reaction, so you make an acid. Acid plus base equals salt plus water. So sodium hydroxide and hydrochloric acid, what you start with. 1 mark then for working out that it's sodium chloride, which you can work out from looking at the names of the salts, and then plus water. Question C, state whether the reaction is exothermic or endothermic. Give a reason for your answer. It is exothermic. The starting temperature is a lot lower than the end temperature, which means the temperature, there's a temperature increase. The heat is exiting. If it had been the other way round, it would have been an endothermic reaction. Moving on then to question number 3, which is quite a nice starting question. You're looking at pH scales, and all you've got to do for 3 marks, so nice, easy 3 marks, is to pick out the strongest acid, weakest alkali, and a neutral base, okay? So the strongest acid is going to be the one closest to pH 0. So in this reaction, or in this pH scale, it's battery acid. Weakest alkali is going to be the one closest to 7. Loads of people are messed up there and put the one closest to 14. The one closest to 14 would have been your strongest alkali. Things closer to 7 are the weaker of the acids and alkalis. And then a neutral substance, pH 7 is neutral, and in this case it is pure water. Okay, John was studying the reactions of acids with 3 different substances, and it gave the observations and the temperature increased. So you have to identify A, B and C from the substances shown in the box below. Straight away I can see that the first one, lime water goes milky. In my head, alarm bells are ringing. That means carbon dioxide has been produced. Carbon dioxide has been produced, which means it has to have come from looking at the box of compounds you've got. It has to be copper carbonate, because that's the only one that would produce carbon dioxide to turn lime water milky. So A was a nice, easy one. Statement B then. No gas produced, substance reacts to produce a blue solution. Like I said again, blue solution, that means you're most probably making, in the end, copper sulfate. So you need copper oxide to react with the acid, which is a black solid, which we have done. Copper oxide, B. Then C, no visible change. So no visible change to me makes me think we're making a salt and a water, because you're not really seeing much happen in that kind of reaction. So to me, I'm picking out which one of them is the alkali, and in this case it is sodium hydroxide, because sodium chloride is a salt and magnesium is a metal. So it's the only one there that I think would have given no visible change. Moving on then to question 4. Again, is a little bit of a graph question, which will come up quite often if you get asked an acid or alkali question. Again, the same kind of setup with the experiment. You've got polystyrene cup, you've got a temperature. This one we're measuring manually with without a computer, and instead of adding it at the beginning, because they're both liquids, you're titrating it in. Okay, again, something you've done in class. The apparatus below can be used to measure the temperature of a neutralizer reaction that takes place, okay? Then you've got 2 different acids. One is obviously stronger than the other acid, and you're looking at the temperature change that takes place, okay? Again, these kind of questions are going to be on more than one page. So in the exam, you'll have them next to each other, so don't worry, okay? Using the graph, opposite, use the graph. Don't just make up your own answers. Volume of acid required to neutralise the sodium hydroxide solution in both experiments. So the volume of acid required, so the bottom one, volume of acid on both of them, your peak, it is at 25 centimetres cubed. So that is the volume of acid required to neutralise. Max temperature rise, again, you're looking for acid B, you're looking for their highest temperature, which was 25, and the starting temperature, which was 23.5. Take them away from each other, and you end up with a maximum temperature rise of 1.5 degrees. State which acid A or B is stronger and give a reason for your answer. Acid A is stronger because it has a larger temperature change, which means it's a more vigorous reaction. Describe how an indicator could be used to find the exact volume of acid needed for neutralization. Indicators, especially ones that are used in titrations, detect tiny changes in pH. So they detect the closer you get to making water, which is the product of neutralization, and they will alter when there's a colour change occurred. So the closer you get to water, you'll start to see a slight colour change. So then you'll be able to work out really closely how much acid was required to get to that colour change. What is the purpose of the polystyrene cup? It is to insulate the reaction, because you're measuring a temperature change. You want to make sure that no heat is escaping and you are still measuring the temperature change.